Alright, welcome back. In our last video, we were looking at how to use the shell command. Okay, this is a shell command. Now the shell command is used to fix up an opening inside a pipe or a machine part. Now we are going to do this 3D piping and then use the shell command to fix in the opening inside the pipe through which liquid or gas will flow. And then we are also going to make this solid machine parts. We are going to model it. Okay, let's go to 2D wireframe so that we can see it clearly. Okay, these are the dimensions. Now we're going to use sweep to get at this piping flow. You know, we did that in one of our previous videos where we use sweep to create a piping flow like this. Okay, so very quickly let's get out our piping flow. Okay, okay, so this is our piping flow line, and then let's get at our circular profile with which we will use to sweep. Now let's take a circle of radius 4, that is diameter 8. So enter. Now we should be very careful that the radius of our circle is known, because from the radius of our circle, which is 4, and of course if radius is 4, we have diameter 8, we can properly design the thickness of our piping plates. Because if the radius of the circle is very big, let's say for example 400, and then we design a piping thickness that is very small, let's say for example 0.5 or 1, we may not be able to see the thickness of the pipe, hence our shell command may not work. Now we have a circle of diameter 8, and hence if we use a shell thickness of around 0.3 or 0.4, between 0.3 to 0.5, it will work. So let's go ahead to quickly sweep this profile. But first of all, before we sweep the profile, let's copy our circles into several places so we can use it for our sweeping operations. Okay, good. So let's go ahead and fillet to give us our elbows. Okay, click on fillet. I get the radius option, which is arrow enter on your keyboard, and then I type in my radius. My radius should be the radius of the circle, and the radius of the circle is 4, so I type in 4 and I enter, and I proceed to fillet all of these bends. So very quickly I go ahead to sweep. Okay, this is the object to sweep. I enter, and then that is the sweep part. Okay, select object to sweep. This is the object to sweep. I enter, and then I select my sweep part. Okay, select object to sweep. I enter, select my sweep part, select object to sweep. I enter. Okay, select my sweep part, select object to sweep. I enter. Okay, select my sweep part, select object to sweep. I enter. select my sweep path, select object to sweep, I enter. Okay, select my sweep path, select object to sweep, I enter. Okay, select my sweep path. All right, select object to sweep, I enter. Select my sweep path, select object to sweep, I enter. I select my sweep path, select object to sweep, I enter. I select my sweep path, select object to sweep, I enter. Select my sweep path, I select object to sweep, I enter, and I select my sweep path. So we have all these as access and we delete them off. Now we go to conceptual and see our piping run. Then very quickly go back to wireframe. The next thing we'll do is to introduce an opening. So very quickly, let's put it back on conceptual. So we'll come to our shell command. You click on shell. When you click on shell, it's asking you to select 3D object. This is our 3D object we select. It's asking us to remove faces. This is the face we want to remove. I click on it and then I enter. Then it's asking me to enter the shell offset distance. Okay, I'm going to enter a shell offset distance of 0.2 and enter. So that is it. You can see that the opening is introduced in the pipe. So this is where fluid, liquid or gas will flow through. Now, like I said before, we should be careful to know the radius of the circle that we are using to sweep. If we have a radius of 500, then our plates, that means the diameter of the pipe is very big. Then our plate thickness should be in the range of 8 to 10 mm. But now we have a radius of 4, which is a diameter of 8, and hence our plate thickness should be small, something in the range of 0.2, 0.3, 0.4, 0.5. So we can also go ahead and do the same thing in the other side. Okay, let's orbit so that we can see this way. To orbit so that we can see. We can also do same thing here. We can also open up this portion. So let me and also open up this portion. So very quickly I come to shell. It's asking me to select solid. This is the solid. It's asking me now to remove faces. This is the face I want to remove. And I enter. It's asking me to enter shell offset distance. I enter 0.2. That's it. So to open it up. So this is the open portion of the pipe. If you come to 2D wireframe, you'll see that we have two circles here now. So this from here to here represents the pipe thickness. So this is 0.2 and this is 0.2. So together you have 0.4. And this is 8. So 0.4 from 8. So you have year to year at 7.6. So internal diameter is 7.6, while external diameter is 8. So that is that for sweep. All right, go back to southeast isometric. Now very quickly to this machine part which we want to draw. Now if you take a close look at this machine part, it has a rectangular base. Okay, and then this part and then this part. Now the rectangular base is 96 by 64. So let's place this here and let's proceed to draw. So for our rectangular base, we can either take a box command and enter 96 by 64 by, look at this thickness, 16. Or we can take a rectangle and type in 96,64 and then extrude by 16. So let's take a box. I take a box, I place this here, and I type 96, 64, 16, and that's it. Okay, I do not want my box to be in that direction, so I want it to be like this. So 96, 64, 16. Let me see my UCS. UCS, enter, M, enter. Okay. Sorry, there's an error message. Let's go back quickly to open up our software. Okay, very quickly, we fix this back in Southeast isometric. Okay, we're still right there in Southeast isometric. So this time around, let me take a rectangular profile and type in 96, 64. Let me take my UCS, enter, M, enter. Okay, this is my UCS. Okay, my Y, okay, my X is taking 96, my Y is taking 64, while my Z is taking. So what I will need to do is I will type in for the rectangular base to be in this direction, because I want to be in this direction. That means I'm going to type 64 first before 96, because 64 has to come first. 64 is what will take X. So I take my box command and I type 64, 96, 16. Good. So that is it. I wanted to fix this direction. So whenever you have this kind of problem, just bring out your UCS to a visible place where you can see it by typing UCS. Tap enter on your keyboard, M for move, tap enter, and then click a place visible where you can see your UCS, so that you can define your X and Y coordinates. This is because I was interchanging the X and Y coordinate. That was why the rectangular profile is facing the opposite direction. So have it in the direction that I want it to be now. So now that I've done the rectangular base, I want to construct this cut here. You see, from this edge to the edge of the cut is 16. So I will use the copy edge tool, which we have used before. This is a copy edge tool. I'll click on the edge I want to copy. I will enter, and then I will take a base point in this direction I want it to go, and I will type in 16. That's it. So I've copied it. Now there is another part of it too, this side, and it's 16 away from the side we have now. So you can use normal copy to copy this 16. Good. So you have it here, and then there's another part of it, this part, which is 20 away from this edge. So I will copy this edge 20 in to get that. So I'm going to use copy edges. I click on the edge, I enter, I take a base point, and I go to this direction, because this direction I want it to go, and I enter 20. Good. So I've copied that 20, and then we have this semicircle, which is 16 mm in diameter. For that, I will take a circle, center radius circle, but before that, I will need to clean up this place. I will trim off all these excessive lines. So I will select everywhere, and I will enter and trim this, trim this, trim this, trim that. Good. So I have my cut here, and then I will construct this semicircle. I don't need any dimensions for that. All I will need to do is place this here and then come to this edge, and that is it. And then I will not clean up this portion by using trim. So I tap on my trim, I select everywhere, I enter, and then I trim it off. This I can delete. So I will now need to pull this cut down by using press pull. So I come to press pull. Remember, we have treated all of this while we are treating the entire tools in this 3D modeling workspace. So take here, I take on my press pull again. Okay, I pull down, and that is it. So I've succeeded in creating this opening here. So the next thing I would do is to come and create this part of the drawing. Now, for me to create this part of the drawing, I need to position this line here, get this face, and then extrude to that area. Now, in AutoCAD 3D, there is what we call the top view, the right view, and the end view, or the end view and the right view, depending on where we are. So for us to know, now this is the top. Now for us to know where will be the right view and the end view, either here or here, we come to look at our view cube. Now before we do that, we have to come to our view. When we come to our view, we have to put our UCS back in this UCS world. So let's tap on UCS world. When we tap on UCS world, we now come here and look at our view cube. From our view cube here, now you can see that, look at it properly. This is front, this is right, this remains top. So that means this is our right, this is our right, this is our, okay, let me look at that properly. Okay, this is our front view, and then this is our right view. This front, and then this is right. So that means this from this way is front, then from this other way is right. That means for us to draw this, we need to be in the front view. So for that, you still come to view, then you come right down to this and place it in front view. Good. When you place it in front view, any of the drawings you are making will now be in this view. Let's try that out and say, let's take a rectangle. Can you see this now? The drawing is now in the front view. Good. So now, for us to do this, we need to use what is called absolute coordinates. Absolute coordinates means typing in X, Y, Z distances. So what we'll do is that we are starting from this point here. We start from this point here, we'll move here 16 and then move here 22 in order to get here. Now if you look at your XYZ coordinates, if you move here, if you are here and you are moving here, that means you are moving X. And then if you are here, you are moving here, that means you are moving Z. Actually, you are moving to the negative side of Z. So that means if you are here, you want to get here, you move X 16. And then you want to get here, you move Z minus 22. Meanwhile, Y will be 0 because you are neither going up nor down. You are just moving here and going like this. So what we'll do is that we'll place our reference, our XYZ origin to be here. So our 0, 0, 0 will be here. So what we'll do is we'll come down to the view. You click on this origin. When you click on this origin, the UCS will just snap to your hand and then you place it here. So this place is now our origin. This place corresponds to here. So right here we have 0, 0, 0. So now we take on our line command. Let's go back to home. Take on line command. When you take on line command, remember we said here to here X is 16. Then Z is minus 22, since you are moving the opposite side of Z, and then Y is 0. So we'll type in absolute coordinate. Now what is X? X is 16, Y is 0, Z is minus 22. Enter. Good. So that is this point now corresponds to this place. So the height here is 28, while the length this way is 40. So type in 28 and then you type in 40. Okay, 28 again and then 40. So that's it. So you have a semicircle here of radius. Okay, we don't have the radius for that. The radius for that we can dimension it. Let's go back to view, pick our 3-point UCS. By the time we come to dimensioning, we will properly understand that. So go this direction and then you come this direction. You come to annotate, you come to linear, and then you dimension this portion. Good. So the diameter of this circle is 24, and hence the radius will be 12. By the time we come to dimensioning and annotation, we will understand what I did just now. So, but first of all, let's know that the radius of our circle there is 12. So come back to home. Come back to home. You take on circle. When you take on circle, this is the center point. You type in 12 for your radius, and then quickly we proceed to trim. You take on trim. All right. You select this. You select this. You select this. Select everything, and then you tap on enter. You begin to trim. Good. So very quickly you select this, select everything here, and then join so that everything will be a single profile. You come to modify, you click on this drop down, and this is join. So you have joined it, everything is now one. So you extrude this way. So I click on extrude. Now you can get the distance to extrude, or you right click and say snap override. When you say snap override, you come here and click on perpendicular. When you click on perpendicular, you cannot get the perpendicular point here that you will click. Good. So that is it. So you have extruded, you have created that face. Now what is remaining to create is this and this. For this, it is easy. All you need to do is to get at this profile and extrude it by 12. Look at this. This is 12. So I take on my polyline command and just go this way, come this way, and do this. Now very quickly, I just select this and extrude it by 12. Okay, can either extrude or press pull. So I type in 12, and that is it. So what is left is this back area. For this back area, we have this as, okay, we have this entire area as 64. From here to here is 64, and then we have the height as 48. So what I would do is to take a line command, go up 48, enter, and then go this way 64, enter. We come down again 48, enter, and then we'll come back 64, enter. So very quickly we have a fillet here, and the radius of this fillet is, let's try and dimension the radius of this fillet. We'll come to 3-point snap. Okay, you come this way, and then you come this way, and then we now come back to annotate. We'll now come to radius dimension, and then we click on this. Okay, it's already union, so it's difficult to get at that radius, but that radius over there is 38. So let's use a radius of 38 to fillet that. It is not dimension, but it's 38. So I come to my fillet, click on fillet, I type enter, type 38. So I radius here and I radius here. Okay, I think that radius there should be, let me Control Z, that radius there should be less than 38. Okay, let me try and get it out. Okay, 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 the radius is 32, so that is the radius. So very quickly, let's right click and say repeat fillet, arrow, enter, 32, enter. So now the next thing we need to do is to extrude. Sorry, but first of all, before we extrude, we need to join first so that we'll have it as a single profile. So I click on join. So everything is in a singular profile now. So very quickly, I tap on extrude, and we are extruding by 16. So that is it there. We are extruding by 16. So I type 16, enter. So that is it. We have succeeded in creating this. We have succeeded in creating this 3D profile. So finally, what we will do is to union it so that we will remove all unnecessary parts of it that are not needed. So I come to union, click on union, ask me to select object, I select everything, and then I enter. Good. So we have now union it, everything is together as one single machine model parts. So thank you very much for watching. In our next video, we are going to dimension and annotate these machine parts that we have created.